So now today's concept is annuity. What do you mean by annuity? See, suppose you want to invest and you have invested in Tata company's bond, and the investment what you have done is $100,000, let's say, and the Tata company has promised to pay you 10% interest for a period of 10 years. So they will make a payment of $10,000 every year. That is the fixed annual payment. Okay? This payment is going to be the same every year for 10 years. When you have such kind of scenarios whereby a fixed payment, fixed equivalent or equal payments. So I'm again repeating, fixed equal annual payments. I'm again repeating, fixed equal annual payments or same amount every year if the company is paying you for a span of, let's say, 10 years or some years till the time the bond matures. Then the concept of annuity comes into picture. This payment, annual payment which is happening, is nothing but an annuity. Okay. Now what is the difference between annuity and normal scenario? Okay, let me explain you. Let's say 10,000. Let's say you have invested $100,000 for 5 years and the rate of interest is 10%. So company is paying you 10,000 for 5 years. And these are the future payments: year 1, year 2, year 3, year 4, year 5. These payments will be receiving in 5 years. So now my question to you is, what is the present value of these future cash flows? So definitely, to find out the present value of these future cash flows, you will be discounting these cash flows. Okay. So I will write the discount factor. Discount factor is 1 by 1.10 whole power 1 for first year, 1 by 1.10 whole power 2 for second year. That will be 0.9090, 0.82. I'll just write it here. 8264. Third year 1 by 1.10 whole cube, 0.7513. 1 by 1.10 whole power 4, 0.6830. 1 by 1.10 whole power 5, 0.6209. So these are the discount factors. Okay, I'll write them neatly here so you can have an idea. What am I trying to prove you? So this is like 10,000 for the first year, 10,000 for the second year, 10,000 for the third year, 10,000 for the fourth year, 10,000 for the fifth year. And the factors are, I'm writing the factors directly. Okay. Now what we'll do is we'll multiply this. Discounted cash flow. We will add all this. You know, 10,000 is at the end of the first year, and at the beginning of the year, the value of this. So that means if you invest 9090 at the rate of 10%, it will become 10,000 at the end of the year. Correct? That means if you compound this 9090 into 1 plus 0.10 whole power 1 will give you 10,000. This is the present value. This is the future value. If I want the present value, then future value by 1 plus r whole power n. That means 10,000 divided by, if I take this that side, 1 plus 0.10 whole power 1. If I do this, I'll get 9090. This is the present value. Okay. So future value by 1 plus r whole power n is present value. Here we did compounding. Here we did discounting. I'm again just brushing up the concept to you. Okay. So we will add up all this. Getting 37,906. Okay. That means this entire value after 5 years, whatever we are going to get accordingly every year 10,000, which is going to become 50,000 after 5 years, is going to be 37,906 as on today. Okay. This is the present value. Okay. Of all these future cash flows. But what I am saying is, all this particular long procedure, you find out the present value of this annuities. That means the fixed annual payments. How? So what we'll do is we'll take 10,000 into present value annuity factor at the rate of 10% for n is equal to 5 years. Now you'll be asking me a question, what is this, sir? See, these annuity factors are available backside of your book in the table. Okay, I'll show you the table. So this 320. So these are the present value of annuity tables. These are the present value tables. We have the requirement of present value of annuity tables. I have taken 10% as my rate. For the span of 5 years, it is 3.791. I will directly take this. Okay. This is very clearly visible. Yeah. So that was 3.791. Okay. So I will take this 10,000 into 3.791. And you know that is again going to be equal to 37,910. Almost it is equivalent to this. Correct? Yes. Hello. Are you understanding who? Hello. So this 3.791 which we took from the table is nothing but if you add all these values, the present values every year, that means 0.9090, the present value of present value factor of first year, plus 0.7513 present value factor of second year, plus 0.6830 present value factor of third year, plus 0.6. Oh, this is like this is third year, this is fourth year, Second year I missed it. I'm writing here 0. 8624, sorry, 8264, 0.6209. If you add up all this, you see what you're going to get. You're going to get 3.7906, that is almost equal to 3.791. Okay, so this is the way to find out the annuity factor. This becomes the present value annuity factor. This is what we have taken here. Okay, and now coming to like when to use this kind of annuity factors. Like one step we got the answer here. Instead of doing all this lengthy stuff, this is the one step to get the answer. But like we have to know when to use annuity and when not to use the annuity. So I'll tell you when to use. Suppose first year, second year, third year, fourth year, fifth year. Every year I'm getting 10,000 as my amount or the payments at the end of each year. Okay. So when you have single payment, you have equal annual payments or the same amounts every year, you should use present value of annuity factor. But when you have uneven cash flows, first year you have 10,000, second year you have 20,000, third year you have 30,000. These are the cash flows you are like receiving every year. 40,000, 50,000. In this case, you cannot use the present value annuity factor to get the direct answer of the present value by taking into consideration this 5 years payments at the end of the year. Here you have to discount them individually every year. You have to take the discount factor for the first year, for the second year, for the third year, for the fourth year, for the fifth year. Okay, so here you have to use the present value factors, not annuity, present value factors. This is the only difference you should understand. Only in this case you can use the annuity. Okay, let's move forward. So here is a question. Imagine we invest $100 at the end of each of the next 3 years. So we are investing $100 in the first year, second year, and third year. And here you can easily understand I'm speaking about annuity because same amounts are invested every year and the rate is 10%. So for 3 years we have to see what is the annuity factor. I told now we can do one thing, 0.9090, 0.8. These 3 years factors we will add. 8264, 0.7513. We will add these 3 years factors. Okay, so now 100 into the present value annuity factor is 2.4867. We get 248.67, and this is your present value of your present value when you are investing this payments of $100 every year, which are the same amounts. Okay, and you can see the answer as well, 248.6, which I gave you here. Fine. Now let's move forward. Here again we have one more question on annuity. what is the present value of $2,000 costs incurred each year for from years 3 to 6? That means 1, 2, 3, 4, 5, 6. From 3 to 6 years, that is the span of 1 year, 2 years, 3 years. In this 3 years, the cost what you incurred every year was $2,000, $2,000, $2,000. And the capital, the cost of capital, that means the discount factor is 5%. Okay. Now what are they asking? What is the present value of $2,000 cost incurred each year from 3rd to 6 years? When the cost of the capital is this. So what we will do is, I don't understand what these people have done, but what we can do from what we have to do, we have to just get the annuity factor from 3 to 6 years, because the investment or the cost is or whatever the payment is happening from 3 to 6 years. So what we'll do is, from 1 to 6 we will take the entire 6 years, 5.076. Hello, who are you able to follow? Hello.
Yes, sir. Hello?
Yeah, you're able to follow, na? Hello.
Yeah, sir.
Yeah, you're able to hear my voice? You're able to hear my voice? Hello.
Yes, sir. Hello?
Hello. Can you hear my voice, Hoor?
Yes,
Hello?
sir, I can hear you.
Hello. Okay,
Hello?
okay, fine. So we are into this present annuity table, and the rate was 5%. It was for how many years? Hello, yes, hello. Just a second. Yeah, can you hear me now? Hello. Hello, can you hear me now? Hello. 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 Yeah. So the cost of capital was 5%, and the time period was how many years? Let's again go back. Yeah. So we will again go back. Sorry, it disturbed our conversation. So we will see the values. What is that? We lost the data. Okay. So it was for 6 years. Fine. So that's the way to do. So we will take the date. We will take from 1 to 6 years at the rate of 5%. The present value annuity factor is 5.076. Okay. The present value annuity factor is 5.076. From 1 to 6 years, whatever the annuity factor 5.076, from that we will remove 1 to 2 years annuity factor, that is 1.859. Okay, then we will get the annuity factor from for 3 to 3 third, fourth and fifth, like 3 years collectively. So that we will see here. So this is what we have, 1 to 6 years. The annuity factor, we have 1 to 2 years annuity factor. From that we have removed, and then we got the discount factor for 3 years, that is 3.217. Now we will take this 2000 which we are investing or which the cost which we are incurring for third, fourth, and fifth year, and we'll take the annuity factor from 3 to 6 years. That is, we have got how by taking the annuity factor from 1 to 6 years, 5.076 minus the annuity factor of 1 to 2 years, 1.859, and we get 3.217. We'll multiply and we'll get the present value. Okay, please have a look through this question. We'll move to the next concept immediately. Any doubts? Please raise it right now. Who I'm waiting. So the next concept is perpetuities. What do you mean by perpetuity? See, now the annuity payments what you are getting for were for 5 years or were for 10 years in my previous examples. But you imagine if you get some annual payments for the entire lifetime, or it would last forever, let's say for the infinite period of time, that means till the time we are alive we will be getting the payments. Then what? Then that kind of annuity payment is called perpetuity. So now you'll be wondering how come this is possible, and did it happen, did such kind of thing did exist? Yes, in the previous times British telecom or British Petroleum, I don't remember the example, they have issued such kind of bonds whereby they ask the people to invest some money, and they promise to give them some fixed amount for the entire lifetime. Okay, let's say, and the formula, let me tell you the formula for perpetuity. The formula for perpetuity is nothing but the bond in which I'm investing, let's say bond price is equal to interest by the rate. Okay, okay, so I'll prove you how. So let's say if the interest payment the British Telecom promised to their citizen was, or the investors was $10, divided by, at the rate of 10% they are giving this $10, 0.10, this is the rate. So the value of the bond will be $100. Okay, that means if anyone has invested $100 in British Telecom, will get $10 every year at the rate of 10%. So if you want, you can do some cross multiplication. $100 into 0.10, that is 10%, is definitely equal to $10. So this is the perpetuity payments. Okay. Please do this, have the look at this concept and try this question here. And we will go for the next concept, that is investment appraisal techniques, the main part or the main concept of this chapter. Okay, please do this question, I'm waiting. Message me if you're not getting, I'll immediately do this. Okay, Yeah, shall we move forward? You're doing this question? Let's do this. If the interest rate is 10%, what would you pay for a perpetuity of $1,000? $1,000 is the amount they are like they want to pay. So in at the rate of 10%, you tell me the answer here. So $1,000 divided by 0.10, $10,000 is the answer. So you invested this much and you'll get this much every year at the rate of 10%. Okay, we'll have a look through this. Sixth question. This is the answer. What? Where did it go? Yeah. So we have already checked that $10,000, and we are moving to the next concept, investment appraisal techniques. So there are three techniques with the help of which you can really understand whether to invest in a project or not. Okay. Definitely what the common sense prevails is any investor would invest in a project if it is a worthy project or a profitable one. Okay. So with the help of these three methods, it will be easy for you to analyze or judge whether the project in which you are planning to invest is a worthy project or a profitable project or not, or whether whatever the investment you are doing into some project is giving you appraisal or not. Okay. So with the help of payback period, NPV method, and internal rate of return method, we are going to discuss or decide whether a project we should take up or we should skip the project. Okay. The criteria to take up the project will only be like whether the only be like considered if the project is a profitable project. Okay. And what is the cost of capital? This is nothing but for any long-term decision making, an important factor is time value of money. We know that with the passage of time, the value of money would change. The purchasing power of money would like go up or would come down. Okay, because I can give an example. 15 years back, one Pepsi bottle, small Pepsi was available for 5 rupees. Today it is available for 20 rupees. Hence, the time value of money or the purchasing power of the currency has gone down. So this is the idea that money today is worth more than the same amount of money in the future. That means today or 15 years back, 5 rupees was a very worthy amount than 5 rupees today. Why? Because 5 rupees 15 years back was enough to buy 250 ml of Pepsi, but 5 rupees today is not enough or sufficient to buy 250 ml of Pepsi, but it can only buy, let's say, if I divide this Pepsi 250 ml into four parts, only we can buy, let's say, around 670 ml of Pepsi with 5 rupees. Okay. So you understood that today 5 rupees can only buy 70 ml, but 75 ml, let's say, just to imagine a figure. But 15 years back, 5 rupees was enough to buy 250 ml. Okay. So today, whatever the currency, today what we have is more worthy than tomorrow. So compensation for this difference. That means, since like today what we have is very important than tomorrow, and like uh, the compensation for this difference. So you can see the difference. 5 rupees 15 years back, 20 rupees today. So 15 rupees is the difference what we can see. So this 15 rupees is what we want to make this 5 rupees worthy for today. That means if this 5 rupees has to become 20 rupees, we want a compensation or extra money of 15 rupees. Then only we can buy Pepsi today. Okay. So that's the reason why the compensation for this difference is known as cost of capital. That means at what rate your 5 rupees can become 20 rupees is nothing but the cost of capital, or the return, or you should get a return of 15 rupees, so that today you above this 5 rupees, so that you can buy a Pepsi of 20 rupees. Okay. So that's what it is we have discussed. Now comes the payback period method. What does the payback period method mean? The payback period method tells you that how much time it will take for you to recover the initial investment whatever you have made in the project. Okay. Based upon that, you can decide whether you what kind of, like, whether you want to invest in a project or not. So I will help you to understand this with the help of my own example, and I will give you the task to do the activities at home. Illustration 6 and activity number. I will explain the advantages, disadvantages as well. Activity, this one you have to do as homework. Okay, let's now understand what does the payback period tell. Let's say I am taking two projects, project 1 and project 2. Here my cash flows are 10,000 and my initial investment is $100,000. I'm getting a cash flow of $10,000, $20,000, $30,000, $40,000, $50,000. $50,000, $40,000, $30,000, $20,000, $10,000. Now, what I mean to say here, as I have invested $100,000, I can see, or easily it can be seen, that project 2 is the one in which I am able to recover my $100,000 in a span of two, like in a span of like between second and third year, I can say. Why? Because I want $100,000. In first year, I got $50,000. Second year, I got $40,000. Now I have $90,000 in 2 years, but I want $100,000, so that I will recover between the second and third year. Okay. So 2 point something, I'll write it 2 point, like I don't know exactly like in how many months I will recover the rest of the 10,000 left over, but 2 point some years will take for me to recover this $100,000. Okay. Now coming to the first year, first project, 10,000, 20,000, 30,000, 30 plus 30, 60, 60 plus 40, 100. So in 4 years exactly, I'm recovering my money of $100,000. Now, seeing this, everyone in the world can say that this is a good project. Why? Because you are able to recover your money in 2 point some years, but I will calculate that how much time it will take. How will I calculate? See how much time it takes for me to exactly recover the like full years. I will take full years. So in 2 years, in two full years exactly, I am recovering 90,000. So 2 years plus. Now I want how much more? I want 10,000. Out of how much? 30,000 in the third year. So please understand, 90,000 I have recovered in 2 years. I took 2 years as base, plus I want how much now to recover more? 10,000 to make it 100,000. So 10,000 I will recover, but out of what I will recover? Out of 30,000. So 10,000 divided by 30,000. And I will calculate this. I'll get 1 by 3. So 2 years plus 1 by 3 of what? 12 months I will take 4. So 2 years, 4 months, it will take for me to recover my 100,000, and here it is taking 4 years. So this is better. Okay. But there's a twist here. That's the only problem with payback period method. Just a second. Yeah. Now, but there's a twist here. The problem is, can you take this project or consider this project too for an investment? If I would have been if I have to pick for me, this would not be a good project. Why? This project is not giving me confidence. Why? Because first year I got 50,000, second year I got 40,000, third year I'm getting 30, fourth year I'm getting 20, fifth year I'm getting 10. These are all decreasing cash flows. If the cash flows are decreasing, it cannot improve the confidence in an investor. It would rather decrease, or it would rather the confidence of the investor will not be high, but the confidence of the investor will go down. Why? Because the decreasing cash flows is not a good sign for a business. It's not a good sign for the business. But here the cash flows are incremental cash flows. So incremental cash flows can build confidence in an investor any point of time. Okay. So this is not good. Just a second. Yeah. So now here, even though it takes 4 years for recovering this $100,000, but still this looks a good project because it builds confidence. It increases the confidence level in me because the cash flows are incremental cash flows every year. You can see here. Okay. But as per the payback rule, this is a irrelevant or not a good project, because payback rule clearly says as soon as possible you recover your investment. That is, as soon as possible, if you recover your $100,000 what you have invested, that project which gives you your payback sooner, that project which is which is helping you to recover, or that project which can recover whatever you have invested as soon as possible. So here it takes only 2.4 years to recover my 100,000. So this project is a worthwhile project as per payback rule. Okay. That's the reason why we don't, or the managements often don't take decision based upon payback method. Why? Because this is not a superior method. Because since even though the cash flows are decreasing here, they are still considering the project. Incremental cash flows has not been given any importance. And aftermath cash flows here you can see. After recovering your money in 2.4 years, they don't even give importance to this particular cash flow. Okay. That is 30,000, 20,000 and 10,000 are irrelevant. Secondly, this particular payback period method is not considering time value of money. And you definitely know that with the passage of time, the time value of money changes. More important today than it will be after 10 years. Okay, that hasn't been considered here. Fine. So these are the drawbacks. Advantages are easy to calculate. Very soon you can calculate your with the help of this method you can easily calculate, and as soon as possible you can know how much time it will take for you to recover whatever you have invested. Fine. So here we can see the advantages and disadvantages. They have no set standards here with which they can the payback period can tell you that how much time you should recover your money in. So maximum period is set is arbitrary. They don't like timing of cash flows is not given any importance here. Ignores any cash flows after the end of the payback. That means after 2.4 years, they are not considering the aftermath cash flows. Time value of money is ignored here. It is easy to calculate and simple to calculate and easy to understand, and it considers the liquidity, that is cash flow. Okay. That means how soon you can recover your money. Now, one small thing I would like to say, as the time value of money was not considered in the payback period method till now, that particular deficiency has been rectified with the help of discounted payback period method. That means previously time value of money was not like considered in payback period method case, but now the things have changed. Now the analysts or the financial managers of the company who wants to decide whether to like invest in a project or not, or which project is giving them the payback or recovering them their money as soon as possible, are now considering discounted payback period method for that case. So I will explain you what is discounted payback period method. It's very easy to calculate. The only change we have to say is what is the change between payback and discounted payback. So I'm explaining discounted payback. So we'll take the same cash flows. Just a second. Now, so discounted payback and like 50,000, 40,000, 30,000, 20,000, 10,000. Discount, what we are doing is instead of finding out the payback directly here, we are going to take the discount factors. And then we are going to find out the payback period based on the discounted cash flows. That's the only difference. So discount factor at the rate of 10% at the rate of 10%. Let's see. So So here also we are going to take the discount factors. And we're going to multiply here. We're going to get 10,000. I'm just going to give this a break. So here what we are saying is, sorry, it's like 9090. So we will see how much time it takes for us to recover $100,000. See, the method has only one difference. That is, we are considering the discounted cash flow. That means we have considered time value of money here, which should be considered. Okay, because in today's, because if you don't consider time value of money, it's a blunder. We already know that with the passage of time, the purchasing power of currency is going to change. Today, what you have is not going to be the same. Today, whatever you have is not going to have the same value in the future. Okay. So here what we are recovering is 9090 plus 16,528 plus 22,539 plus 27,320 plus 31,045. That means in 4 years, let's say in the fourth year, plus see till here we are recovering how much, I will tell you. We are recovering 77,470, sorry, 75,477 in span of 4 years. But we want 100,000. So we will receive, we will recover the balance amount between like balance amount is 100,000 minus 75,477. This balance amount will recover between the fourth and fifth year. Okay. Between the fourth and fifth year, we are going to record the balance amount. That is 24,523. Okay. Out of what we are going to recover this 31,045. So how much time it will take? It's going to take 0.7899. So 4 years plus 0.7899 into 12 months. So 9.47, that means 4 years plus 9 months. It is going to take you to recover your $100,000. And we will see in this case how much. So 45,450 plus 33,056 plus 22,539 is almost 100,000. So we are going to take this 2 years. 2 years. In 2 years, we are recovering 78,000 recovering 78,506. We want how much? 100,000. 21,494 we want. And out of 22,539, we are going to recover that. So 0.95 into 12. That means 2 years plus 0.95 you're getting into 12. So 2 years, 11 months we are going to take to recover our 100,000. So this is a good project as per payback period. But I tell you, that I will not make my decision based upon payback period because I already have told you the drawback of payback period method. Okay. So this is the concept of payback. The time. Yeah. Now the next two methods we are going to do are only NPV and IRR. So next class, I'm going to finish NPV. If I'm free, I will take that tomorrow itself and close this chapter and go for the standard costing. Okay, Hur? Done? Tomorrow, next class, whatever it is, this chapter would be done. Okay? Hello? Fine? Then see you in the next class. I'll inform whether we have the class tomorrow or not. Thank
Yes, sir.
you.
Okay.
Yes, sir. Okay.
Yeah.
Okay,
Thank you.
sir.
Please go to this
Thank you,
concept.
sir.
Yeah. Thank you. Thank you.
Yeah, sure,
Yeah,
sir.
sure.
Thank you.
Yeah. Thank you.